Welcome to G Fun Facts Online. For all of human history, the stars have been distant, unreachable points of light. We've looked up and wondered, but the sheer scale of the cosmos made interstellar travel seem like a fantasy reserved for science fiction. But what if that's changing? What if we are on the cusp of a technology that could take us to another star system within a single human lifetime? This isn't about warp drives or wormholes. This is about something far more tangible, riding on a beam of pure light. This is the story of laser propulsion, a technology that could transform our civilization, reshape our economy, and redefine our place in the universe. The fundamental idea is deceptively simple. We know that light, specifically photons, carries momentum. When a photon bounces off a surface, it imparts a tiny push. It's an infinitesimally small force, but in the vacuum of space, with no friction, these tiny pushes can add up. If you have a powerful enough laser and a large, lightweight sail, you can accelerate a spacecraft to incredible speeds. This isn't just theory anymore. The physics is sound, and a global community of scientists and engineers are tackling the immense challenges to make it a reality. There are two main paths being forged for this technology. The first is the one that captures the imagination, the light sail. Picture an incredibly thin, highly reflective sail, perhaps kilometers wide, attached to a tiny, sophisticated probe. From Earth, or from an array in orbit, a gigawatt-scale laser. A laser with the power output of a nuclear power plant fires a concentrated beam of light at this sail. The relentless pressure from the photons pushes the sail and its payload, accelerating it continuously. The Breakthrough Starshot initiative is the most famous example of this concept. Their goal is to send a fleet of nanocraft, probes the size of a postage stamp, to our nearest star system, Alpha Centauri, which is over 4 light-years away. By pushing them with a 100 gigawatt laser array, these probes could reach 20% of the speed of light. At that velocity, a journey that would take tens of thousands of years with our current chemical rockets could be completed in just over 20 years. Imagine that. We could launch a probe and receive images of a planet orbiting another star within our lifetimes. The second approach is less ethereal, but perhaps more practical for work closer to home. This involves using lasers to energize a propellant on a spacecraft, essentially a laser-energized rocket. Instead of a sail, the laser beam is focused onto a block of propellant on the back of a spacecraft. The intense energy instantly vaporizes the material, creating a high-velocity jet of plasma that thrusts the spacecraft forward. This method provides much higher thrust than a light sail, making it suitable for larger payloads and for maneuvers like escaping Earth's gravity. A variation of this is laser-electric propulsion, where the laser beam provides power to a highly efficient electric engine on the spacecraft, like an ion drive. Think of these systems as creating a photonic railway throughout our solar system. A permanent, ground-based laser installation could be used to launch and accelerate cargo and crews to any destination, slashing travel times and costs. While reaching the stars is the ultimate dream, this photonic railway could revolutionize our own solar system first. Let's talk about what that really means. A trip to Mars with our current technology takes about 6 to 9 months. This long journey exposes astronauts to dangerous levels of cosmic radiation, causes bone and muscle loss, and presents immense psychological challenges of isolation and confinement. Now, imagine a future with laser-electric propulsion. A trip to Mars could be cut down to just 45 days. This isn't a minor improvement, it's a complete game-changer. It dramatically reduces the health risks for astronauts, making long-term missions and even permanent settlements far more feasible. With rapid, regular transit between Earth and its colonies on the Moon or Mars, we would truly become a multi-planetary species. This would create a new kind of human society, with new cultures, new challenges, and new forms of governance for off-world settlements. The economic implications are just as profound. The initial investment would be enormous. Building a gigawatt-scale laser array would be one of the largest and most complex engineering projects in history, likely requiring a global consortium of nations and private companies. However, once that infrastructure is in place, the cost per launch could plummet. This would democratize access to space. Universities, small companies, and even well-funded individuals could afford to send their own probes and experiments into the solar system. This opens the door to a new era of space-based industry. Asteroid mining could finally become economically viable. Near-Earth asteroids are packed with valuable resources like platinum group metals, iron, nickel, and, perhaps most importantly, water. Water can be broken down into hydrogen and oxygen for rocket fuel and breathable air. These resources could be used to build and supply space colonies, reducing the immense cost of launching everything from Earth. The photonic railway could move raw materials and components quickly and cheaply between asteroids, orbital factories, and planetary bases. We could construct massive solar power satellites in orbit, beaming clean energy back down to Earth. The vision is of a bustling, interconnected solar system, a true extension of the human economy. But the impact of laser propulsion goes beyond economics and logistics. It touches on the most fundamental questions of our existence. Sending swarms of tiny, fast-moving probes to nearby star systems would revolutionize the search for extraterrestrial life. For centuries, we have been limited to peering through telescopes, trying to decipher faint signals from light years away. With laser propulsion, we can send robotic emissaries to get a direct look. We could receive close-up images of exoplanets, analyze their atmospheres for biosignatures like oxygen or methane, and perhaps one day even land on their surfaces. The discovery of life on another world, even simple microbial life, would be one of the most profound and transformative moments in human history. It would force us to reevaluate our place in the universe and confront the reality that we are not alone. The very act of becoming an interstellar species would have a deep philosophical impact. Astronauts often speak of the overview effect, the powerful sense of awe and global unity they feel when seeing the Earth from space, a pale blue dot suspended in the blackness. Knowing that humanity has a foothold on other worlds, that our destiny is not confined to this single planet, could amplify that effect on a cosmic scale. It could foster a greater sense of shared identity and purpose for all of humanity. However, this grand vision is not without its challenges and perils. The scale of the required laser infrastructure is daunting. The materials for a light sail need to be incredibly lightweight, strong, and reflective, pushing the boundaries of nanotechnology and materials science. We also need to solve the problem of keeping a laser beam perfectly focused on a tiny sail across millions or even billions of kilometers. Then, there are the ethical questions. If we find life on another planet, what are our responsibilities? Should we interfere with its potential development? The prime directive from Star Trek, the principle of non-interference, would shift from a science fiction concept to a very real and pressing ethical debate for humanity. And perhaps the most serious concern is the dual-use dilemma. It is impossible to ignore the fact that a gigawatt-class laser capable of pushing a spacecraft could also be used as a weapon. The ability to direct that much energy with pinpoint accuracy over planetary distances raises significant security concerns. Any serious development of large-scale laser propulsion must be accompanied by robust international treaties and verification systems to ensure its peaceful use. The path to the stars is not just a technological one. It is a journey that will challenge us to be collaborative, forward-thinking, and ethically responsible. The history of human exploration is a story of overcoming seemingly insurmountable challenges. The great voyages of discovery weren't undertaken because they were easy, but because they were hard and because they promised to expand our knowledge and our horizons. Laser propulsion is our generation's equivalent of the great sailing ships of the Age of Discovery. It is the technology that could open up the vast, uncharted territories of the cosmos. It offers a future where humanity is not a species of one world, but a true citizen of the cosmos. The journey will be long, and the challenges are great, but the destination, the stars, is a prize worthy of our grandest ambitions. The age of sailing on beams of light is dawning, and with it, a new and brilliant chapter in the human story is waiting to be written.